So we'll make it a little bit more difficult now, and we are going to incorporate some chain rule with some product rule and some quotient rule and all that kind of good stuff. So what I have now is a t squared times a 5t plus 3, and that's cubed. So what's your bigger picture? Your bigger picture, when you step back and look at this, is you've got this chunk times this chunk. So we know that we got to do product rule. But within product rule, we're going to have to do some chain rule because the derivative of the inside is not 1. Okay? So product rule is the bigger picture. So I've got the first, which is t squared, times the derivative of the second. So I'm going to drop my 3 out front, times what's sitting there, drop my exponent by 1, and then times the derivative of the inside. So I've got first times derivative of the second plus the second times the derivative of the first, which is 2t. So now you can clean this first one up a little bit if you want. By 5 times 3 is 15t squared times 5t plus 3 squared plus 2t times 5t plus 3 to the third. Okay, it just makes it a little bit cleaner. All right, so let's try another one. We have the square root of u plus 1 times 1 minus 4u squared to the 8th. Okay, so first of all, first thing I see, I don't want that radical there. Okay, I cannot manipulate a radical numerically. So that's going to be a u plus 1 to the 1/2 power times a 1 minus 4u squared to the 8th. And now again, what's your bigger picture? Now that we got it in a format that we can work with, I got this chunk times this chunk. So I know it's going to be product rule. And I just got to be careful along the way. Now pause for 1 second. I'm going to cover this up. If this was the only problem, if that was the only part, we would not have to use chain rule. Because what's the derivative of the inside? It's just 1. Okay, so we've been doing this the whole time. It's just that we haven't really noticed it yet. All right, so I've got the first. So my derivative is going to be u plus 1 to the 1/2 times the derivative of the second. So first times derivative of the second, which means I have 8 times 1 minus 4u squared to the 7th times the derivative of the inside, which is a negative 8u. Okay, so first times derivative of the second plus the second, which will be 1 minus 4u squared to the 8th, times the derivative of the first. So you get a 1/2 u plus 1 to the negative 1/2. Okay, and if you want to do chain rule, it's then times 1. Okay, because it's times the derivative of the inside. Now, for those of you who are saying, holy cow, this is a long way, there's got to be a shortcut, please remember that this is the shortcut. Okay, this is the shortcut. The long version is your limit process with the difference quotient. So this is the shortcut. All right, so let's do another one. I got an s to the 7th plus a 1 over s, all raised to the 5/2. So the first thing I notice is I better fix this thing. Okay, I better fix him because he's messy. So I'm going to come over here and make it an s to the 7th plus an s to the negative 1 raised to the 5/2. Okay, now I've manipulated it, so it's easier to work with. Next question is, do I have to use chain rule? My bigger picture is I've just got one chunk raised to the 5/2 power. I'm going to have to use chain rule because the derivative of the inside is not 1. So start by dropping your 5/2 out front, times what's sitting there, drop your exponent by 1, and now times the derivative of just the inside. So that's going to be a 7 s to the 6th minus s to the negative 2. Okay, so drop this, drop it by 1, drop this, drop it by 1. Okay, so now I got, ooh, this is nasty. All right, so I've got a 5u squared over u squared plus u to the 3rd. Okay, so what's my bigger picture? I got variables divided by variables. But what do I notice? I've got another clump in here, and the derivative of the inside is not 1. So that tells me that in the process of quotient rule, I'm going to have to use chain rule. So I'm going to write tiny. That means I've got the bottom. So I have u squared plus u to the 3rd. Bottom times the derivative of the top, which is a 10u, minus the top, which is a 5u squared, times the derivative of the bottom, which is 3u squared plus u squared, times the derivative of the inside, which is 2u plus 1, and you better put that thing in parentheses. Okay, so bottom times derivative of top minus top times derivative of bottom, all over the bottom squared. So u squared plus u to the 3rd again is going to be to the 6th. Okay? And again, if you want to clean that thing up, you have fun. All right, so I want to find an equation of a tangent line to a graph at a given point. So again, we're going to go through this thing from start to finish. I have a function. My function is 1 minus x times x squared minus 2 squared. So this, if I FOIL stuff out and distribute and do all sorts of stuff, I'm going to end up with a negative x to the 3rd, which I don't want to do all that stuff. Okay, the point that I'm given is going to be a 2, negative 4. So the first thing I want to do is take a derivative. Because what do I need to find the equation of a tangent line? To find the equation of any line, I need a point and the slope. So the derivative of this will tell me the formula for slope. So my derivative. So what's my bigger picture? I got this chunk times this chunk. Okay? So my bigger picture is product rule, but I'm going to be having to do some quotient rule along the way. So I've got the first, which is 1 minus x, times the derivative of the second. So 2, x squared minus 2 to the 1st. Okay? First times derivative of second. Don't forget about your derivative of the inside. Okay, so I've got the first times the derivative of the second plus the second times the derivative of the first, which is a negative 1. Okay, so that is my formula for slope for any tangent line to any given point. So my given point has an x of 2. And if you'll notice, right now, all we have is x's. Okay, later on that's going to change. Just FYI. All right, so I want to take my derivative, and I want to evaluate it at 2. So now that gives me a 1 minus 2 times, good grief, I'm going to catch up with that one. So x squared is 4 minus 2, and then I've got 2 times 2 times 2 is 8. Okay, plus, then I got 2 squared is 4 minus 2 is 2 squared times negative 1. So what have we got here? I have 1 minus 2 is negative 1. 4 minus 2 is 2 times 8 is 16. So I get a negative 16. And then 2 squared is 4 times negative 1 is negative 4. So that gives me a negative 20. So my slope at this specific point, the slope of the tangent line is negative 20. So now can I find the equation of the line? Yes, I can. So y equals mx plus b. My y value is a negative 4. My slope is a negative 20. My x is 2, and I need to know what b is. I need to know what my y-intercept is. So now I've got a negative 4 equals negative 40 plus b. So add 40 to both sides, and we find out that the equation of the tangent line, I've got a slope of negative 20, and he slices through the y-axis at positive 36. So that's the equation of your tangent line. Okay, so we got one more to do, and it's a heifer. Okay, I got f of x is, and I've got x plus 3 over x minus 1 squared. And this is going to be the 0.5 comma 4. So again, I want the equation of the tangent line. I've got the x, I got the y, I need the m. Okay, I need the m. So look at this bigger picture. The bigger picture is I got this chunk raised to the second power. Is the derivative of the inside 1? No, it's not. So we're going to have to take the derivative of the inside, and that's going to involve quotient rule. Okay, so my derivative is going to be, drop your exponent out front, times what's sitting there, drop your exponent by 1, so it's just to the first, and then times the derivative of the inside. So now I need to use quotient rule. So I've got the bottom, which is x minus 1, times the derivative of the top, which is 1. Okay, minus the top, which is x plus 3, times the derivative of the bottom, which is 1, all over the bottom squared. Okay, so because I can multiply anything by 1, I don't care about those. This thing is, I'm just going to rewrite. So I got a 2x plus 3 over x minus 1 times x minus x is no x's. Negative 1 minus 3 is negative 4 over x minus 1 squared. Okay, so 2 times this times this. And now I'm just going to shove in a 5. Okay, so when I evaluate this thing at 5, I'm going to get a 2. 5 plus 3 is 8. 5 minus 1 is 4. And I got a negative 4 over 5 minus 1 is 4 squared is 16. Okay, so what I get for an answer, well, this reduces with this. Okay, so what I get is a 16 that's negative over 16, which is negative 1. Okay, so that whole thing reduced down to a negative 1. Well, now I got an x and a y and an m. So if y equals mx plus b, my y is 4, my m is negative 1, my x is 5, and I need to know where it slices through the y-axis at. So I'm going to add 5. So I get 9 equals b. So the equation of the tangent line to this graph at the point 5, 4, which is the one point that they have in common, is y equals negative 1x plus 9. And now we are done with section 3.